This is for Year 12 Specialist. It comes out of 8B question number 12. Show that the area shaded yellow is 2. Okay then, so I know that I need to find this intersection point. When I find the intersection point, I can set up my integrations. So let's say that angle is P, so that there is P. So I'm wanting the integral from 0 to P of the blue curve, which is 4 sine x dx, plus the integral from P to pi on 2 of 3 cos of x dx, and that's going to be my area that I'm looking for. Okay, so how do I find this intersection point? It's going to be when this equals this. So 4 sine of x equals 3 cos of x. Since I've got a sine and cos, I'll create a tan. So sine of x on cos of x will equal 3 on 4. Therefore, tan of x equals 3 on 4. Which means that x equals the inverse tan of 3 on 4. And that's going to be P, the angle that gives you the inverse tan of 3 on 4. Therefore, the tan of P has to be 3 on 4. I know that P is in the first quadrant, so if I was to draw a gradient triangle, and that's P, and that's 3, and that's 4, therefore that's 5. So I also know that the cosine of P will be 4 on 5, and the sine of P will be 3 on 5. Okay, so let's go back up here. This is going to be 4 cos of x, but negative, from 0 to P, plus 3 sine of x from P to pi on 2. It's got negative 4 cos of P plus 4 cos of 0 plus 3 sine of P minus 3 sine, that's pi on 2, and that's sine of P. So I've got negative 4, cos of P is 4/5 times 4/5 plus 4 plus 3 times sine of pi on 2 is 1, so that's 3 minus 3 times 3/5, which gives me minus 16 on 5 plus 7 minus 9 on 5. Minus 9 minus 16 is minus 25 on 5 plus 7 minus 5 plus 7. My answer is 2. So I've shown that that area is actually equal